11th International Physics Olympiad year 1979 IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Message me if interested. My email is fred1996@hotmail.com, or you can use Skype name Eduard F 1996. Problem number 3. During the Soviet-French experiment on the optical location of the Moon, the light pulse of a ruby laser lambda equal 0.69 micrometer was directed to the Moon's surface by the telescope with the diameter of the mirror d equal 2.6 meters. The reflector on the Moon's surface reflected the light backward as an ideal mirror with the diameter d equal 20 centimeters. The reflected light was then collected by the same telescope and focused at the photodetector. Question 1. What must the accuracy to direct the telescope optical axis be in this experiment? Question number 2. What part of emitted laser energy can be detected after reflection on the Moon if we neglect the light losses in the Earth's atmosphere? Question number 3. Can we see a reflected light pulse with the naked eye if the energy of single laser pulse E equal 1 joule and the threshold sensitivity of eye is n equal 100 light quantum? Question number 4. Suppose the Moon's surface reflects alpha equal 10% of the incident light in the partial angle 2 pi steradian. Estimate the advantage of using a reflector. The distance from the Earth to the Moon is 380,000 kilometers. The diameter of a pupil of the eye is d equal 5 millimeters. Planck constant is h equal 6.6 multiplied by 10 power negative 34 joule by second. Solution for problem number 3. Question 1. What must the accuracy to direct the telescope optical axis be in this experiment? Solution. The angular resolution of the optical system is estimated by the aperture diameter and the wavelength of light. By the Rayleigh criterion, 2-point sources are considered resolvable when the main diffraction maximum of the airy disk of one image coincides with the first minimum of the airy disk of the other image. If the distance is greater, the 2 points are well resolved, and if less, they are considered unresolved. Rayleigh established this criterion for sources of the same intensity. Taking in account diffraction through a circular aperture, the expression for the limiting angular resolution is written as delta phi approximately equal 1.22 lambda over d, where lambda is wavelength and d is diameter of telescope. But since we use a fairly rough evaluation criteria, we can approximately assume that delta phi equal approximately lambda over d, and thus the beam divergence angle delta phi caused by diffraction determines the accuracy of setting the optical axis of the telescope. So we have delta phi approximately equal lambda over d, or about 2.6 multiplied by 10 power negative 7 radians, or approximately 0.05 seconds. Solution for question 2. What part of emitted laser energy can be detected after reflection on the Moon if we neglect the light losses in the Earth's atmosphere? Solution. The part K1 of the light energy of a laser directed to a reflector may be found by the ratio of the area S1 refractor versus the area S2 of the light spot on the Moon, where S2 equal pi r square and r equal L multiplied by delta T, where L is distance to the Moon. So we have first coefficient K1 equal S1 over S2, or this expression. The reflected light beam diverges as well and forms a light spot with the radius big R on the Earth's surface. And again we have big R equal lambda multiplied by L over D, as small r much less than big R. That's why the part K2 of the reflected energy which got into the telescope makes K2 equal big D square over 4 big R square, which is this expression. And the part K0 of the laser energy that got into the telescope after having been reflected by the refractor on the Moon equals to K0 equal K1 multiplied by K2, or approximately 10 power negative 12. That was solution for question number 2. Question number 3. Can we see a reflected light pulse with the naked eye if the energy of the single laser pulse E equal 1 joule and the threshold sensitivity of eye is equal about 100 light quantum? Solution. The pupil of a naked eye receives as less a part of the light flux compared to the telescope as the area of the pupil SE is less than the area of the telescope mirror ST. So we have Ki equal K0 multiplied by Si over S telescope, which is about 3.8 multiplied by 10 power negative 18. So the number of photons big N getting into the pupil of the eye is equal to total energy E, which is 1 joule over energy of 1 photon multiplied by Ke, which is about 12. So the number of photons N getting into the pupil of the eye, since big N less than small n, one cannot perceive the reflected pulse with the naked eye. Question number 4. Suppose the Moon's surface reflects alpha equal 10% of the incident light and the spatial angle 2 pi steradians. Estimate the advantage of using a reflector. Solution. In the absence of a reflector, alpha equal 10% of the laser energy that got into the Moon, dispersed by the lunar surface within a solid angle θ1 equal 2 pi steradians. The solid angle in which one can see the telescope mirror from the Moon constitutes omega 2 equal S telescope over L square, which is pi d square over 4 L square. That is why the part K of the energy gets into the telescope and it is equal to omega 2 over omega 1, which is about 0.5 multiplied by 10 power negative 18. Thus, the gain beta, which is obtained through the use of the refractor, is equal to K0 over K, which is 2 multiplied by 10 power 6. That was solution for the question 4. And that was full solution for problem number 3.